NEC Table 430.52 addresses motor branch circuit, short circuit, and ground fault protection. It's used to determine the maximum size of overcurrent protection devices, such as circuit breakers or fuses, for motor circuits. The table values are based on the motor's full load current rating and design letter, not the specific application like an air compressor. To determine the appropriate overcurrent protection for an air compressor motor, you first need to identify the motor's full load current, or flow, which is typically found on the motor's nameplate. The nameplate also might include a design letter such as A, B, C, D, E, F, G, H, I, J, K, L, M, N, or O, which affects the allowable overcurrent protection. Next, consult Table 430.52. The table is divided into different columns based on the type of overcurrent protection being used, such as inverse time circuit breakers, fuses, or instantaneous strip circuit breakers. Select the appropriate column for the type of overcurrent protection you are using. Find the row corresponding to the motor's design letter if applicable. If the motor does not have a design letter, use the values for motors with no design letter, which are typically design B. The table provides a percentage or multiplier that you apply to the motor's full load current to determine the maximum allowable size of the overcurrent protection device. For example, if the table specifies a maximum of 250% for inverse time circuit breakers for a design B motor, and the motor's FLA is 10 amps, the maximum allowable circuit breaker size would be 25 amps. 10 amps times 2.5 equals 25 amps. It's important to note that the overcurrent protection device should be sized to protect the motor and the branch circuit conductors from overloads, short circuits, and ground faults, while also allowing the motor to start and operate without nuisance tripping. The NEC also allows for the use of overload relays or other types of overload protection in addition to the overcurrent protection device. These overload relays are designed to protect the motor from overheating due to sustained overloads. In some cases, the NEC permits the use of the next highest standard overcurrent protection device size if the calculated value does not correspond to a standard size. However, this is subject to certain limitations and requirements outlined in the code. Always refer to the latest edition of the NEC and consult with a qualified electrical professional to ensure that motor branch circuits are properly protected and comply with all applicable requirements. Article 430 covers the application and installation requirements. Air compressors typically use induction motors. Induction motors are AC electric motors that are widely used in various industrial and commercial applications, including air compressors. They are known for their reliability, efficiency, and relatively simple construction. Induction motors operate on the principle of electromagnetic induction, where a changing magnetic field in the stator induces a current in the rotor, which in turn produces torque. The two main types of induction motors are square cage induction motors and wound rotor induction motors. Square cage induction motors are the most common type of induction motor and are widely used in air compressors. They have a simple and robust design with a rotor consisting of conductive bars embedded in slots and connected by end rings, forming a square cage-like structure. Square cage induction motors are known for their high starting torque, efficiency, and low maintenance requirements. Wound rotor induction motors have a more complex construction with a rotor consisting of coils of wire connected to slip rings. External resistors can be connected to the slip rings to control the motor's speed and torque characteristics. Wound rotor induction motors are typically used in applications where high starting torque or adjustable speed control is required. Air compressors commonly use single-phase or three-phase induction motors, depending on the size and power requirements of the compressor. Single-phase induction motors are typically used in smaller air compressors for residential or light commercial applications, while three-phase induction motors are used in larger air compressors for industrial or heavy-duty applications. The choice of motor type and size for an air compressor depends on factors such as the required airflow rate, pressure, and duty cycle. The motor must be sized appropriately to provide sufficient power to drive the compressor pump and maintain the desired air pressure. In addition to induction motors, some air compressors may use other types of motors, such as synchronous motors or direct current, or DC motors. Synchronous motors are AC electric motors that operate at a constant speed, synchronized with the frequency of the power supply. They are typically used in applications where precise speed control is required. DC motors are electric motors that operate on direct current power. They are commonly used in portable or battery-powered air compressors. When selecting a motor for an air compressor, it's important to consider factors such as efficiency, reliability, starting torque, and environmental conditions. Motors should be energy efficient to minimize operating costs and reduce energy consumption. They should also be reliable and durable to withstand the demands of continuous operation. Motors with high starting torque are preferred for air compressors to ensure smooth and reliable starting under load. Motors should be selected to operate within the specified temperature range and humidity levels of the environment. Proper motor maintenance is essential for ensuring the long-term performance and reliability of air compressors. Regular maintenance tasks include lubricating bearings, cleaning motor windings, and inspecting electrical connections. Motors should be protected from moisture, dust, and other contaminants to prevent damage and premature failure. In summary, air compressors typically use induction motors, with square-cage induction motors being the most common type. The choice of motor type and size depends on the specific requirements of the compressor application. Proper motor selection, installation, and maintenance are essential for ensuring the efficient and reliable operation of air compressors. The NEC provides guidelines for motor circuit protection based on the motor's full load current and design letter.